Well, good morning and welcome, Math 3 students. We are here already at week 2, and this is lesson 1 for the week, and it's all about polar coordinates. So all of this time we have been working in the coordinate plane, and we have been measuring some rotational angles starting on the positive x-axis at 0 degrees, also known as 0 radians. And if we rotate counterclockwise, we reach straight up at 90 degrees, which is also pi over 2. If we keep going, straight left on the negative x-axis is 180 degrees, which is also 1 pi radians. And then straight down on the negative y-axis is 270 degrees, also 3 pi over 2. Now, of course, if we go all the way around, we get back to 360 degrees, which is also 2 pi radians. Now that we know that there are just over 6 of those radian angles, the exact number is 2 pi radians in every circle. So in the coordinate plane, we typically use x and y. That tells us how far to go left and right on the x-axis, and then how far to go up and down on the y-axis to put us in that two-dimensional space. But in the polar coordinate plane, we actually use r and theta instead of x and y. So r tells us the radius, how far away from the origin or the pole to go out, and theta tells us what rotational angle we need to be at on these circles. So for example, if the radius is 1 unit, well, we would be somewhere on that first circle because it is exactly 1 unit away from the origin or the pole. If the radius is 3, we would be on the third circle somewhere because each of those, well, every point on that circle is exactly 3 units away from the pole. So let's take a look here at example 1. We're trying to locate point A, which is at 245 degrees. So the 2, that's the radius. That tells us which circle to be on. So 2 units out from the pole will be on that circle. And specifically, the angle we're located at is a 45-degree angle. So on this second circle, if we rotate up to 45 degrees, that is point A. We don't need to draw the actual radius, although we certainly could. But we don't need to draw it in because we're just locating the point. Here on example 2, point B is located at 3 pi over 4. So you will run into some radian angles on Delta Math. So the 4 tells us that we're going to be on the 4th circle out, somewhere on that 4th circle. And our angle is 3 pi over 4. Well, if we know that rotating to 180 is 1 full pi, well, here we're looking at 3/4 of pi. So if we break that up into 1/4, 2/4, 3/4, that's where we would be located on the radius of 4, the 4th circle out, and the angle of 3 pi over 4. That's one way to do it. Or you can certainly use the conversion factor of taking 3 times 180 and divide by 4 to come up with the degree measure. Here in example 3, we have point C that we're supposed to locate at 12 pi over 5. So the 3 tells us, of course, that we're on the 3rd circle out, and we need to locate 12 pi over 5. This 12/5, that's an improper fraction, and it's also greater than 2. If I were to convert 12/5 into a mixed fraction, that would be 2 and 2/5. 2 and 2/5 pi. So 1 full rotation is 2 pi. So we're past 2 pi and on our way to 2/5 of pi. So if we broke up the 180 degrees or the single pi into fifths, well, 2/5 of it would be somewhere around here, roughly. So that's point C. But again, you could instead take pi out, put 180 in its place. So 12 times 180 divided by 5, and hit enter instead. And it's a 432-degree angle. Subtract a 360-degree rotation and 72 degrees. So that seems to fit in with the 2/5 of pi idea where we placed point C. And lastly, example 4, point D is located at -2, 60 degrees. So what do we do if the radius is negative? Well, we're still going to locate the original point to 60 degrees, and then we'll deal with that negative. So 2 would put us on that second circle. 60 degrees would be roughly here on our way to 90. But the fact that it's a -2 radius means that we need to go exactly halfway across the circle in the opposite direction of where the +2, 60 degrees would have been. So point D is located exactly across a 180-degree rotation from where we were. So this video turned out to be 6 minutes long. Sorry, guys. I hope you have a great day.